Chapter 3, Section 3, Properties of Logarithms. We are going to review exponent rules, and then hopefully you're going to see how they relate to the properties that we're going to deal with today. So I want to remind you that if I have a to the x times a to the y, it equals a to the x plus y. If I have a to the x divided by a to the y, then it's a to the x minus y. Quick reminder, we've already used these, but anything to the 0 power is 1. Anything to the 1 power is itself. If I have a negative power, I'm going to say negative n, it's 1 over a to the n. And then because some people need to see this, if I have 1 over a to the negative n, it would become a to the positive n on top. We also have the power that says a to the x to the y, means I multiply my powers. What other properties will help us? I don't know. I think these two are probably the most helpful that we have. So when we get down here for our properties of logs, a is a positive number such that a doesn't equal 0. So in other words, a doesn't equal 1. A is greater than 0 and a doesn't equal 1. N is any real number. If u and v are positive real numbers, then the following properties are true. So the product property says if I have log base a of u times v, this is called expanding a log, and if I go backwards, it's called condensing a log, which we'll get to. Then because these arguments are multiplied, I can break it into two separate logs. Log base a of u, plus log base a of v. So if you go back up here and look, here when we multiplied our bases, we added our powers. Here, if our arguments are multiplied, we can separate it and add our logs, as long as the bases are the same, okay? Quotient property. If I have log base a of u over v, then I can do log base a of u. Division goes with subtraction, so this will be minus log base a of v. In this one, it's very important that the top always becomes the first argument, and then the minus and the log of the bottom, which is the second argument. The power property. The power property is a really good one, too. We have, if I have log base a of u to the n power, where if you remember right, n is a real number. What I can do, and this is one of those patterns that Ms. Phillips loves so much, is as long as the power is on my entire argument, it can come around and become a coefficient or a constant multiple is what it's called sometimes, in front of my log. Okay? So, in example 3, they want me to take the examples or the problems that they've given me and rewrite them in terms of Len 2 and Len 3. In other words, they want their answers to specifically use Len 2 and Len 3. So I'm going to say that I know 6 is 2 times 3. So since that's multiplied arguments, I could break it up into Len 2 plus Len 3. The next one, there's lots of ways to do this. I'm going to give you what I think is the most efficient way. This is natural log of 2 divided by 27, and 27 is 3 to the third power. I don't really want to do 3 times 3 times 3 because that's a whole lot of doing it out, and then I'm just going to combine them in the end. So this, because it's division, breaks up into Len 2 minus Len of 3 to the third. So that uses our quotient property, but then we can also use our power property. We'll notice that that 3 power was only on the 3, so it only goes to that Len. So the correct answer for this one would be Len 2 minus 3 Len 3. All right. The next one, example 4, using the properties. Let's say we want to find the exact value of this log without using a calculator. So log base 5 of the cubed root of 5. Well, we learned once upon a time that radicals are really just exponents written a different way. So this is the same as log base 3, log base 5 of 5 to the 1/3 power. The power stays up, the root goes down. The root's underneath it. Thank you to Nora Poling for saying that so many times in class that I would remember it. Then my power can go around to the front. I have 1/3 log base 5 of 5. Well, if my base and my argument match in the, I think it was section 3.2 notes, they told us that that equals 1. So 1/3 times 1 is 1/3. All right, so in the next video, we will be expanding and condensing logarithmic expressions.